Okay, so today we're going to talk about set symbols. So there's a few symbols that you guys need to be able to identify and interpret what they mean and apply those. So the key idea for today is that mathematicians use symbols to communicate in a shorthand way, and sets have an accepted set of symbols that are used. Okay, so we're going to use the following sets to demonstrate some important symbols and terminology. So you've got the set H, which is the numbers 1, 2, and 3, the set P, which is the numbers 1, 7, and 8, and then the universal set, which is n, such that n is less than 10 and n is a natural number. So what that means, if it's a natural number, those start at 1, and we'd have 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so that's what that universal set is composed of there. Okay, so a few symbols that we need to know. The first one is this element symbol. Okay, so if you see an E, hopefully you've seen this before as like X is an element of the real number set. And that is, we've been kind of doing set notation without actually realizing X is an element of the real number set. That is a set, okay? So we could also say, in this case, we could say 2 is an element of H, because you can see there's a 2 in the set we called H. If you've got the element symbol with a line through it, that means it's not an element of. So if we look at set P, it contains 1, 7, and 8. So 6 is not an element of P. Okay. So those ones hopefully are pretty self-explanatory. The next one is a subset. So it's kind of like a sideways U. It kind of looks like an extended little C, but it means subset. So it means the first set has some or all of the elements in the second set. Okay, so this individual set 1 and 7, which we could give a name if we wanted to, we could call it Q or L or squid, or it doesn't really matter, we can name it. But this set is a subset of P, meaning that P contains 1 and 7, and we've just chosen some but not all of P. Okay, so this set is a subset, meaning that it came out of elements in P. Okay, a union. Okay, so this one looks like a little U without a spigot thing on it. So a union essentially means or. Okay, so if we have two different sets, if we're looking at a union, we're looking at elements that are in the first set, the second set, or both. Okay, so if we said H union P, we're looking at elements that are in the first set, the second set, or both. So 1, 2, 3, 7, and 8 would all be in the union of H and P. Okay, remember from yesterday that we're not going to write 1 twice, even though it appears in both. We don't want any repeats in our sets ever. Okay, so that's a union. So when you think of union, I want you to think or. I'm going to write that again, even though it's just right there. The next one is what we call an intersection, and then its symbol is an upside down union. So that gets a little bit confusing. We'll talk about how to remember it in a second. So an intersection means and. It's in both the first and the second set. So again, an intersection, this symbol is kind of like and, okay? So the intersection, H intersect P, the only one that's in both of these is a number 1. Okay, so the only intersect is that 1. Okay, the way that I remember is a union kind of looks like a happy face. So it's happy because everyone's included. A intersection kind of looks like a sad face. This is sad because not everyone included. Okay, so think of a happy face, everyone's included, or a sad face when you're trying to remember the difference between union and intersection. Union's also a little bit easy because U and U, union starts with U and this looks like a U, is the other way, but I like the happy and sad because it actually makes you think of what it means. Okay, so if it's a smile, everyone's there. If it's a sad face, it's just the people who are in both, not everyone's included. Okay, the next one is a circle with a line through it. So it looks like a 0 with a line through it, or an O. And this means the null or empty set. Okay, so if nothing's in the set, you can either detail it with this or an empty set, and we'll talk about that. This often gets pictured when we have what we call a disjoint set. Okay, so if we wanted to look at the intersection, remember this upside down U is an intersection. If we wanted to look for the common things between 1 and 2 and 7 and 9, there is none. So we're going to use that null, that there's nothing, to detail that there is no intersect between those. Okay, this is what we would call a disjoint set. Okay, an apostrophe is what we call a complement. And so I touched on this briefly yesterday, so we're going to go in more detail today. So the elements not given in the set. So the complement of the union, so if we take the union of H and P, so remember that's this guy up here, and we want to know the complement of it. That means the things that are not in this union, not in this set. If we go back to, okay, we're starting at this universal set. If we look at the ones that aren't included here, we'd have 4, 5, 6, and 9, because 1, 2, 3, 7, and 8 are included. These ones are the nots. Okay, so we'll go through some examples. The complement is what's not, and then U is the universal set. So in this case, the universal set, as I said up there, was 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so we'll go over some ways to draw this. Again, universal set, yesterday we looked at the universal set is generally in a box, and then we might have subsets in circles. Okay, so we looked at some subsets yesterday without actually realizing it. We could say, so because the natural numbers fit inside the whole numbers, we could say the natural numbers are a subset of the whole numbers. We could say the whole numbers are a subset of the integers. The integers are a subset of the real numbers. Because remember that circle from yesterday? You can look at it again if you don't remember, but it went natural and then whole and then integers, and this whole box, I'll kind of try and draw it. I didn't give myself enough room. So the whole box would be real. So natural, whole, integers, real. Okay, so there's the subsets. So we're going to go through some examples. So we're going to find an element of the set A, and the set A is integers that are less than 10. Okay, so we're going to use these symbols up here. So we're going to actually use the element symbol. So I'm going to just pick an integer. So I'm going to say 3 is an element of A. So again, in words, this would be 3 is an element of A. If we want to find an element that's not of the set C, and the set C is even prime numbers, we want a prime number that is perhaps not even, or we could do a number that is not a prime number. So I picked 7, which is a prime number, but that's definitely not even. So 7 is not an element of C. So again, 7 is not an element of C. Okay, next example, we're going to find a subset with 2 elements of the set D. Okay, so we're gonna look at this set D, and we're gonna find a subset of it. So first, I'm gonna actually look at what numbers would go in D. Okay, so factors of 24. I have 1 and then 24. I have 2 and 12. I have 3 and 8, and I have 4 and 6. Okay, so 1 times 24, 2 times 12, 3 times 12, or sorry, 3 times 8, and 4 times 6. Okay, those are my factors of 24. So a subset, let's call it, I don't know, let's call it Q, because I like the letter Q. So I can just pick whatever numbers out of here that I want. So my favorite numbers happen to be 2, 4, and 8. Okay, so we could say that Q is a subset of D, because all of the things in Q are contained in D. If we wanted to draw a picture, we could say if this is Q, it exists within D. Okay, so we did that yesterday. We just didn't know it was called a subset yet. The next example we're going to look at is find the complement of Q. Okay, so this is Q, 1, 3, 5, 7, and 9, which is part of the universal set. So it's the box that would fit containing all one-digit whole numbers. So one-digit whole numbers are 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so the complement, the one that it's not included in Q, would be 2, 4, 6, and 8. Because all of those other one-digit whole numbers are included in Q. These are the ones that are not. Okay, so that would be the complement of Q. Then we want to find the set containing all negative perfect squares. Remember, perfect squares are something that square root perfectly, right? Like a nice even number. So if we want a negative square root, we run into an issue because a negative square root isn't actually going to exist, right? If I want a number that multiplies by itself to get to a number, that's not going to exist with one positive and one negative. And two negatives would multiply to a positive. So you can't have a negative perfect square. So this set, I'm going to call it P for perfect, is that empty set. So we can either draw it like this, or we can say P is equal to that null symbol. There's nothing in that set. Okay, so those are the two ways that you can do that. We're going to find the complement of M. So this one's integers divisible by 2. So this one's kind of written in words. So instead of trying to list all of the integers that are not divisible by 2, I'm just going to write that. Integers not divisible by 2. And then last thing, we're going to find the intersect of sets A, 1, 2, 3, and 4, and B, 6, 7, and 8. Okay, so if we want A intersect B, we're looking for things that overlap. And hopefully you can see that there are none. Okay, so this is an empty set. Okay, so we could also write it as A intersect B is nothing. Okay, so what's this called when there are no common items? Remember that this is called a disjoint set. And how can we represent this visually? So in the universe, all the numbers that we could pick from, this would be A, and this would be B. There is no overlap. So we talked a little bit yesterday about Venn diagrams. This would be a Venn diagram that doesn't actually have any overlap. Okay, so a few more examples. So we're going to sketch the following using sets. The universal set is the students in a class. So their names are Claudia, Denise, Earl, Fred, Grant, and Henry. Okay, so they would all fit inside this universal set. The set L is all the girls, and the set O is just Claudia. So we know that the girls are going to fit within that universe. And then within that, because Claudia is a girl, assuming people have, you know, the assumed gender name here, Claudia is going to be by herself in her own subset. And then Denise and Claudia would both be in that girl circle. And then Earl, Fred, Grant, and Henry are all going to be outside in the universal set. Okay, if we wanted to talk about a subset, we could say Claudia is a subset of the girls. So notice Claudia is called set O, and the girls are called set L. So we could say O is a subset of L. Okay, So this is O, this is L, and then this is the universal set. Technically, I think your U is supposed to have the little cappy things on it. It's always like that if it's typed. Okay, so hopefully that makes sense. A few more examples in that same class as above. So Claudia, Denise, Earl, Fred, Grant, and Henry again. We're gonna set N. So we have a set called N, and it's gonna group the students who have 5 letters in their name, okay? So N would be Grant and Henry, because they both have 5 letters in their name. We're going to draw a set diagram. So again, this is set N, and it's going to have Grant and Henry in it, and then Claudia, Denise, Earl, and Fred are outside. Okay, what's the complement of N? So this is saying everything that's not in this set called N. So the N complement of N would be C, D, E, and F. Claudia, Denise, Earl, and Fred. Okay, so this, essentially, anything outside of that set N would be the complement of N. This example we're going to express in set builder notation. So using a math rule, the set L is 0, 1, 4, 9, 16, blah, 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 blah. So first we have to figure out the patterns here, okay? So these are perfect squares. Okay, so they are the whole numbers squared. So we have 0 squared, and then 1 squared, and then 2 squared, and 3 squared, and then 4 squared, blah, blah, blah. Okay, and that pattern continues because we have that dot, dot, dot there. So in set builder notation, we would say, okay, L is X such that X is equal to, okay? So in this, we need to assign some other variable that can represent these changing numbers. So I'm just gonna call it A, because it's another common variable. And whatever A is, if A is 0, it needs to get squared. Or if A is 1, it needs to get squared. 2, it needs to get squared. Now we need to give this set a rule to make sure that A is a whole number and it's a positive whole number. Okay, so we're going to say A is an element of the whole numbers. Okay, you could have also done A is an integer, A is an element of the integer. And A is greater than 0 or greater than equal to 0. So there's a few different ways that you could write this, but there is a math rule of set builder notation for that set. Last one, we're going to express in set builder notation, again using a math rule, the set K. So we have dot, 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 so that means it's extending this way, the pattern. So you go -9, -10, -11, because then it goes -7, -8, -7, -6. Then there's a break and we resume at 6, 7, 8, and then it dot, dot, dots again. So 9, 10, 11, 12, blah, 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 blah. Okay, so K is equal to, say, X such that, okay? So X has to be less than or equal to -6. So X is less than or equal to -6. Or, okay, and because we're going to practice our union symbol, we're going to actually use a union symbol because we know that union means or. Or X has to be greater than or equal to +6. And in both of these cases, X has to be an element of an integer. We only want positive or negative whole numbers. We don't want decimals or fractions. So we're going to say that X has to be an element of those integer sets. Okay. For practice, you guys should now be able to do the rest of lesson 1 on set theory in the Snap Notebook. So you can read 51 to 56 and then do questions 1, 2, 7, 8, and 9. Or whichever ones, if you didn't do 3, 4, 5, 6, you can do those too on pages 57 to 60. If you have any questions, let me know.